Hi, thank you for joining the webinar today. We will start momentarily. Let's give a couple minutes to wait for some people to join, but we're excited for your time for the webinar and looking forward to share the next hour with you. Thank you. Okay, it's about 5 minutes past the hour, so let's get this webinar started. So welcome to another Juniper webinar. We have a special guest today. PacketFabric is joining us to discuss the next leap into cloud networking. My name is Robert Tang. I'm part of a service provider product marketing team focusing on network automation. I'm your host. We have two distinguished guests with us today, Anna and Tim. Anna, would you like to introduce yourself?
Good morning, everyone. My name is Anna Claiborne. I'm a co-founder and SVP of Software Engineering with PacketFabric.
Thank you, Anna. Tim?
Yeah, thank you, Robert. My name is Tim Kovic. I'm a senior systems engineer with Juniper Networks, and I've been working with PacketFabric for several years now on their project.
Great, thank you, Tim. We'll kick off our webinar today with why engineering simplicity and automation matters. Tim will provide an overview of automation technology at the network infrastructure level. This is to be followed by Anna, where she will describe how PacketFabric automated cloud networking. We'll close this webinar with a brief summary and Q&A session. We'll have some polling questions in between. Let's start with engineering simplicity and automation. Network traffic continues to explode. And according to a study by our partner Ericsson, it's estimated that the total network traffic will reach about 71 exabytes by 2021. In parallel, our network has also undergone a transformation. It has evolved from a purposely built legacy network into a dynamic cloud-based architecture. So as both consumer and enterprise service place exponential demand on the network with multitude of requirements such as scalability, reliability, and speed, our ability to manually manage this increasingly bigger and complex network remains stagnant. This eventually leads to challenging in maintaining network reliability. And traditionally, the cost of operating a network is much higher than the cost of building a network. So the ratio of OpEx to CapEx for a typical service provider is about 4 or 5 to 1, and OpEx to revenue is about 70%. While we can extend this ratio by increased OpEx, and assuming that's available to address bigger network, it will simply at best, prolong the inevitable. In light of this exponential growth, network reliability eventually breaks down if we were to continue with manual operation and processes. And here's when engineering simplicity comes in. Engineering simplicity is essentially augmenting our ability to manage network efficiently via network automation. So we can effectively address the scalability, agility, and most importantly, the reliability that modern network service demand today. So with that, here's our first poll question. What's the single most important key driver for network automation? It is a reduced cost, Is it reintroduce new services? Is it scalability? Or it is operational efficiency? We'll pause for a minute or two for the audience to input the answers. Okay, I'll take a couple more seconds, but thank you for inputting your answer. I see the answer coming in. Okay, let's see what our audience has submitted so far. Now we see actually the most frequently cited answers are actually of operational efficiency. And in between, there's a reducing cost and scalability, essentially tied to second. And this is actually along the line we have observed so far with both our service providers and enterprise customers. Thank you for submitting, and now I would like to transfer this portion to Tim.
Thank you. So we're going to just a couple of slides here today on specifically how Juniper leverages automation, builds automation into their products, and kind of what the overarching goal is to achieve by doing that. So what this slide really shows here is that automation is pervasive throughout our entire platform. In every operational vertical, from the access tier to the aggregation tier, all the way down to the smallest branch office, we see automation being used today in very enlightening ways. So what triggers that, or what allows us to be so pervasive with our automation? And the answer to that is Junos. So Junos allows us to run the same features or the same automation capabilities that you would see on one of our higher end core boxes, all the way down to one of our campus switches. And we do that through at 5 different levels within the box. Streaming telemetry, management plane APIs, control plane APIs, forwarding APIs, and finally different protocols to allow us to use automation. And it's important to recognize here that kind of where we're going with this whole concept is we want to get our customers to the point of what we would refer to as a self-driving network. A network that they can stand up, they can automate the actual turn up of the network, they can receive feedback from the network in terms of streaming telemetry, and then they can manipulate the network and monitor the network going forward, be able to react to different changes in the environment via an automated path. So that's our goal. We want to get the customer to the point of being able to input the business logic, being able to input the operational processes into an automated platform, and then allowing that automated platform to take care of the day-to-day, the adds, moves, changes, and those type of functions. And that frees up your networking staff to do more higher level business analysis type things, to innovate, and ultimately to have a greater return on the functionality of your network. So this next slide talks about the tools that we make available to the customer enable them to put this automation into place. And we have a full stack of automation capabilities available, some provided by us. Most of them are strictly open source. So this allows the customer to determine what best suits their environment. Maybe they're an existing Ansible customer and they're using Ansible on their compute platforms. You're able to leverage that in-house knowledge to be able to just shift that over to your networking platforms as well. So starting at the bottom, from a prepackaged solution, we have Python scripts, Ansible models, netconf libraries, ZTP, and other tools that we make readily available to the customer. Plenty of documentation behind them, plenty of educational services behind them for the customer to easily introduce into their network. And the beauty of it is that you don't necessarily have to be a programmer and able to leverage these tools. Obviously, many you do, but we try to make the entry point into automation as painless as possible. ZTP is a fine example of that. We often see customers using zero-touch provisioning as kind of a first step. And then we move further up the scale into using some of our more extensive toolkits. Python scripting, we have Python native on our platforms, and we see customers leveraging that time and time again to automate those, pull
monitoring information out.
And then finally, the highest level is our APIs. And these truly unlock the power of automation within our platforms. They are obviously more complex. However, once we see users get familiar with the APIs that we provide, we do see automation just kind of take off at that point. And PacketFabric is kind of a shiny example of that. We love working with customers who can use these tools and who can really take them to the next level. Not only, I think, does it benefit customers, but it really benefits us as well, because we're able to naturally learn from the customer. So with that, I think I will hand it off to, I believe, Robert. We have a poll question coming up there.
Thank you, Tim. Yeah, this is now, we have a second poll question, and going along the line that Tim discussed earlier in terms of Juno support different multiple open automation framework. So the question now is, which of the following network automation script or framework that you have deployed today? Is this Ansible? Is it SaltStack? Is it Chef or Puppet? I will pause here for a minute too for the audience to enter their answers. The answer are coming in, so we'll give a couple more seconds for audience to enter their choice. Thank you. Okay, here are the poll answers, and we see as today's Ansible is a prevailing choice of as a third-party automation framework that the audience has used today. Now I would like to transfer this portion of the webinar to Anna. Anna?
Good morning again, everyone. So the first question we're going to answer today is, who is PacketFabric? There's a lot of terms floating out in the market today to describe different solutions as far as SDN or SD-WAN, and all of them can take on their own meaning depending on how they're implemented. So to put it in the most simple terms, PacketFabric is a secure networking services platform, and we offer layer 2 transport, cloud connectivity, and business-to-business connectivity that enables businesses to grow and scale on their own terms. And what our customers do with these capabilities is they leverage them to build really sophisticated wide area networks, data center to data center connectivity, backbones, peer with networks they need to exchange traffic with, and also connect to one or many cloud platforms for dedicated private connectivity to those cloud platforms. And so what else, to get our heads wrapped around a little bit more what it is PacketFabric offers, is that we are a network provider that behaves and looks a lot like a cloud computing platform. Over the last 10 years, we've seen this whole evolution in cloud computing where, it's gone from the days of racking, stacking, configuring servers to now you can hit an API endpoint, or you can go to a UI and you can configure 1,000 or a single server in just a few minutes. However, there is no parallel to that currently in the networking world except for PacketFabric. So of the things you can do with this is, like we discussed already, you can instantly connect to many different cloud computing platforms. You can add capacity to your network or virtual connections to whomever you wish on the platform in 30 seconds or less. We have a publicly available REST API for automation and really deep integration with our services. So you can perform everything from automated turn-up and deployment of network ports to virtual connections to complete automation of tear-up and tear-down of a whole nationwide network. Along with all this automation comes extensive troubleshooting tools that are built in and real-time information. So you can look at everything from optical light levels to traffic on physical and logical interfaces to errors to drops. And in addition to the visibility that we provide for network, we also have some pricing that is different from traditional services, that you can do anything from month to month all the way up to 60-month terms with discounts. And the month-to-month thing, that's one of the biggest differentiators to traditional networking services, and definitely more along the lines of what people are used to seeing in the cloud computing arena is, much shorter term usage cycles for any resource. And so to compare a little bit more precisely against traditional network services, what PacketFabric is that for those of you who have dealt with traditional networking services on the call today, is that you have, a relatively typically long sales and negotiation cycle that can last anywhere from 40 to 90 days because there is no published pricing. So you're, doing contracting, you're doing price negotiation, which is based upon, who you are as a customer usually. After the contracts are signed, it goes into manual service provisioning where you get transferred between different groups. Can take anywhere from 30 to 90 days. You're usually on several different turn-up calls with different groups. It's going back and forth of, why isn't a cross-connect working? Why isn't a light level working? Why isn't paperwork I've been issued correct? And then finally, when you get to the end of that, you have your service, and if you ever want to make a change to that service, you're going through the exact same process again. With PacketFabric, there's a web sign up. We have click-through contracts. You click through master service agreement. You click through everything else. We have online readily available pricing, both on our public website within our portal. You click or use the API to provision services. That takes about 30 seconds. You can also run, we have a suite of testing tools that you can use to verify and test your connection. Takes about 2 minutes. After that, you have an operational service, and if you want to upgrade that service, you simply follow the same path again, so your total investment time is just a couple minutes. And to dive a little further into the specific offerings, what does it mean when it's, what does connectivity mean on the PacketFabric platform? You can connect at any speed from 1 gig to 100 gigs. So that's just simply, that is a actual physical port on our network, and it's a cross connect that you run to that physical port. If you turn up a 100 gig port connect to us, that means you have 100 gigs available to run anywhere over the network. As far as the real-time statistics that are available, we covered those. I went into a little bit of detail on those already, which we'll see a little bit more in the demo. But there's quite a few available there that are consumable either via the UI or the API. You also get a lot of valuable business information as far as how much usage, because we do have usage plans as another differentiator from dedicated, committed transport. We have usage plans, which we provide a lot of detail on exactly how much and where you've used any usage over the network. And also that's part of our larger, easily accessible billing information, which you get access to, all your invoices, detail line item charges, everything over, again, the portal or the API. So you never have to wait for a bill or lose bills. Those are always very easily accessible. And so where are these services actually located? Right now we're available in over 150 US locations, and we have locations in Europe and Asia Pac coming in 2019. This information, again, is available on our public website. You can see the URL down there actually in the lower right-hand corner of the slide. So if you want to check it out, you can go there. You can even export that data in JSON format. So how does this wonderful automated network that we've built work under the scenes? This is a high-level architectural view of the PacketFabric network. And you'll see on the left-hand side, we have the PacketFabric portal. And that is built entirely upon our core API and our metrics API. So we do follow an API-first architecture very heavily. That's why any functionality that is available via our portal is also available via our API. It will always be available via the API first. Now getting into the next layer behind this is that we have our software network controller, which if you want to think about it, this is the software-defined networking portion of the architecture. And this is what controls all the logic, business rules, the intent of it's what translates the intent of the network that you're building into the actual practical network that you want to build. And we have two storage bins that go under this. And that's the configuration DB and the real-time network database. The configuration DB is, again, the intent. So it records all the parameters like what you would like the rate limit to be on a particular connection, VLANs in use, where you would like a port to be, where you would like virtual circuits to be. The real-time database is the network representation of that. So it's updated every 30 seconds, actually off of the network itself. And the reason for this is because, as all of you know that have operated networks, is that sometimes bad things happen. Line cards crash, things don't work out exactly like you wanted them to work out. So what ends up actually being functional is you have a port or a connection or something that's had to be moved in an emergency state to another location. And unless you have a way to either update your configuration database with this information or track it somehow, those changes are lost. And so that's why we constantly have two different things, the intent of what was provisioned and the reality of what was provisioned. And the intent, if we follow along here through the diagram, goes down to, you know, we do some pretty extensive queuing to make sure that we lose no information. And eventually it goes into a configuration engine, and this is what translates the command. This is what translates, you know, what you want to build into the actual netconf. And now we get into, you know, why we chose Juniper is because Juniper has so many options for interacting with it in a programmatic fashion. We chose netconf because, you know, we're fairly experienced with this stuff. It's easy for us to work with netconf. They also have a lot of great libraries that we do still use sometimes for prototyping, like PyEZ. But for all of our production systems, we interact directly with the routers using netconf. And again, Juniper has a really great, stable implementation, full implementation of netconf that you don't have to worry about things not working on, which is great. So for the other side of this, so what we've done is basically wandered down the path of how we push a command from the UI to actually get it on the router. And if we go the opposite way, to look at how we get information out of the routers, like, for example, how do we monitor optical light levels off the router? Well, we do that through a combination of streaming telemetry and netconf RPC calls, depending on what's available. We run a QFX line of Juniper, and there's still a few telemetry items that aren't on there, which is why we run a combination of both. And so when available, we always choose streaming telemetry to get information off. And if not available, we use netconf as a backup to pull that information. That goes again, and that goes into a time series database. It's information read every 30 seconds. This is what is pulled directly by our metrics API and seen in the portal. So that was a fairly extensive dive there into the architecture. And now we're going to go ahead and jump into a demo and see what this actually looks like. All right, so everyone should be able to see my screen now. And I'm actually going to just wait real quick for confirmation of that before I proceed. And it looks like I'm actually going to log out of this account and log into another one, as there's already information in there. All right, so no one is confirming that they can see my screen, but I'm just going to assume that everybody can.
We can see it.
Okay. Okay, thank you. All right, so we're going to go ahead here. I actually already have a couple ports provisioned, but the first thing we're going to run through is provisioning a port on the platform and how that works. So we're going to go ahead and we're going to choose create a single port. You see here we have options to create multiple ports or even create lags. And we are going to provision this in LAX. And we're going to, and right here we can filter sites and we can go ahead and choose which site we want. We're going to go for core site in LA1. Here we can choose speeds from 1 to 100 gigs. We're going to go with a 10 gig because that's all we really need for the demo today. And here we select our availability zone, so either zone A or zone B. You can think about this as very analogous to cloud availability zones. So it represents the underlying hardware, and you can pick diversity in all the underlying hardware. So we're going to go ahead and select zone A here. For port description, we're going to call this core site LA1 port 1. Here we select a billing account, so we can have multiple different billing accounts if we would like billing to go to different groups within the organization or billing to go on different POs. Select a subscription term, so anywhere from 1 month to 36 months. We're going to go ahead and select month to month. Down here we see a summary of our order, the location, the pricing. We're going to go ahead and hit place order. And this little box tells us that our port is now provisioning. If we need an SOS, a physical record from this, we can go ahead and download it here. And then after the port is done provisioning, you can generate an LOA to submit to your provider to run the cross connect. So we can see our core site LA1 port is here. And it will take about 30 seconds to get provisioned. So we'll give this just a few minutes, or well, a few seconds really. And we can see that our port status for the core site LA1 port 1 is now active. Here we can generate an LOA. We can also put a different name on the LOA if the name that you are doing business as at the colo provider is different than what you've registered with PacketFabric with, which happens a surprising amount. And here's the LOA that we submit to our provider to get the cross connect run. And now let's go in, we'll take a few seconds here just to look at the statistics available. Well, we actually don't have any data here yet, but we're going to review what would be available as soon as this port is up, is that we have bytes per second, packets per second, total bytes and total packets transferred. You can look at these values from any date range specified as far back as 6 months. We also have resource and total drops available, as well as any framing, CRC, or multicast, unicast errors available to view. So now that we have this port here, we're going to do something with it. So we're going to go ahead, we're going to build two different connections to Amazon. We're going to build a hosted connection, which is over shared infrastructure to get to Amazon, and we're going to build a dedicated connection to get to Amazon, which is ports and virtual circuits strictly dedicated to you as a customer. So we're going to go here to Packet Core, which is Packet Cloud On-Ramp. We're going to hit Add a New Service and select Packet Core Hosted to Amazon. Here we're going to build a public connection. So public connections are to S3 AWS services. Private is to your VPCs within Amazon. We're going to select a source market So we're going to go with LAX, and we're going to select our core site LA1 port 1. And then we'll select a destination. So this is the Amazon region that we want to connect to. In this case, since it's LA, we'll say that we're going to US East 1, North Virginia. We select a speed, 1 to 10 gigs. We'll just do a 1 gig connection. And we're going to call this a dedicated S3 connection. Again, we can choose the billing account to send this to. We're going to enter our Amazon account ID. This is a test Amazon account ID of ours. We're going to choose our source VLAN, and we don't have anything provisioned on this port yet, so we can choose anything, but I'm going to go ahead and just start at VLAN 100. We're going to enter our ASN. I'll have the system automatically generate a BGP key here for me. Now we need to pick our point-to-point /30s. So I'm just going to go with private IP address range. So pick 2 contiguous /30s, and then we also need to advertise to Amazon at least the IP address that we're giving to them, or we could just advertise the full /24, I guess. And we'll go ahead and generate packet core. And it tells us when we're done, we need to go visit Amazon to finish provisioning. Since that isn't really relevant to this demo and we have some time constraints to work with, I'm not going to show the Amazon provisioning side. And so we hit OK. And we can see that our direct, S3 connectivity is here being provisioned. It's administratively up, operationally down because we still don't have our cross connect run to the other side. But that is provisioned and ready to go as soon as we provision it on the Amazon side. And now we're going to go into, so that is the shared or hosted connectivity, and that is run over. We have a bunch of aggregated ports to Amazon that are shared for that connectivity. So those are run from your dedicated source port to a shared Amazon destination port that's shared among many customers. Now we're going to show the dedicated version of that in which the customer owns both the source and the destination port and can build as many virtual circuits as they would like freely between those 2 points. So we're going to choose the packet core dedicated. We're going to select our core site, LA1 port 1 as our source. And then as our destination, we're going to choose an Amazon endpoint. And for this one, we'll do a slightly different Amazon endpoint. We'll go ahead and select core site SV3 in San Francisco. So this is the Northern California region. And we're going to select a 10 gig endpoint. So we can use a full 10 gig of as many different VCs as we'd like between these 2 points, as well as a hardware availability zone. And here we'll choose zone B. And we will call this our demo dedicated Amazon connection. And along with this, we also build the first virtual circuit that we'd like to provision from our source to our destination. So here the system automatically fills in the next available VLAN on our source. If you remember, we used 100 for our hosted, and then the first available VLAN, which is 4 on our destination. And we select our term for this. We'll go ahead and select a 12-month term. We see our pricing down here, a summary of our order, and we'll go ahead and hit Create Packet Core. And here we have our demo dedicated Amazon connection. It's requested and currently provisioning. Again, this will take about 30 seconds to a minute to provision. And in the meantime, we're going to go back and take one look here at our port that we provisioned. just to look at, or actually we're going to look at one of these guys, just to take a look at the optical light levels. So here we can see our transmit and receive, since that's one of the few statistics we can start collecting without a cross-connect and actual traffic running. And we can actually go down here and take a look at module temperature too, or that should be coming through. No. And this is the end of our demo time. So I'm going to end the screen share now. And I believe that we have, oh no, just kidding, sorry. One more slide. So now that we've taken a look at both the high-level benefits of using a cloud networking platform, the specifics in architecture, as well as an actual demo of how to use it to practically connect and establish connectivity to a cloud provider, you know, what does this actually get you as a customer? It actually results in really substantial time and cost savings. You get about a 99% reduction in provisioning time for any service, be that a physical interface or a virtual circuit or a cloud connection or provisioning to a third party, because you're talking about 2 minutes versus a traditional, versus 45 days. It's about an 83% cost savings in provisioning. And a lot of that results not just from, it's a lot of time that is saved with manpower and resources on your side, but it's also reduction in provisioning costs that you can get through automation. And even after provisioning, you get about a 65% faster resolution of issues just due to the amount of troubleshooting information that is available in the portal and the amount of testing, which we didn't cover in the demo, but you can thoroughly test all those interfaces and cross-connects before you put them in production. And we have a poll question coming up, so with that, I will switch it back to Robert.
Thank you very much, Anna. And yes, this is the next portion is another last poll question. So I think Anna has shared a lot of interesting statistics with us, and the questions pertain to OPEX. So what OPEX saving have you achieved as a direct result of network automation? So it's under 5%, 5 to 10%, 10 to 15, 16 to 20, or 20 and above? I would pause here for a minute for everyone to input their answers. Thank you. Okay, I think we look at the answer right now. I think it's mostly in terms of about OPEX saving is as a result of automation is about 5 to 10%. That's an interesting trend as well here. So before we open up to our general Q&A, first of all, thank you, Anna and Tim, for this webinar. And I'd like to quickly summarize on what we have discussed today. So from both consumer and enterprise service place exponential demand on the network with multitude of requirements in terms of scale, reliability, and speed. Our ability to manually manage this increasingly complex network remains stagnant, and network automation is the only solution. We have seen earlier from PacketFabric how to leverage Open API to create an open automated solution that instantly establishes network connectivity. And one of the many features included deep integration with the existing provisioning tool and network monitoring solutions, thereby creating a truly closed-loop automation. So thus, we have seen tangible results in terms of cost, time, and incident resolution as demonstrated by PacketFabric. With that, I will conclude our webinar today. Thank you very much for Anna and Tim again, and we're open to general questions.
All right, so it looks like we do have one question here. I'm going to go ahead and read it for everybody. It says network automation is a journey consisting of multiple stages and processes. And the question is, now that PacketFabric has successfully implemented an automated network connectivity, what is the next step? Which is a great question. The next steps in terms of features is nearly unlimited. We have a roadmap that's 100 miles long. And a lot of what we plan to implement is even greater visibility to the network and greater features and flexibility on what you can do with it. Like, for example, some of the upcoming projects are a latency map across the entire network. So in real time, customers can view latency from any point to any other point, as well as monitor and consume that information and use it to make decisions about what to do with their traffic on the network. And that's just one example of how we plan to really, bring network automation to the next level, is by opening it up even greater in terms of visibility. And we have one more question here. What are your considerations in choosing Ansible, and have we considered other automation tools? Yeah, so our primary consideration in choosing Ansible is the fact that Ansible is generally quick to deploy. It's very easy to use. There's also existing integration with the Juniper, some of the Juniper libraries, which made it super fast for us to do a prototype using Ansible, and we eventually just converted that to production. We do have, we are in kind of a middle place right now where we're actually converting a lot of our internal systems to Salt, because Salt is just a lot better at parallelization, and it's a much more robust framework. But Ansible is absolutely fantastic for getting up and started and scaling out, and then eventually I think everybody hits a point where they do outgrow it, and we are coming very close to that point. But still, it's a great system to start with because it allows you to get going so quickly. And looks like just one more question here. The question is, those are some impressive business results that you shared. From your customer perspective, what are the most important attributes: time, cost, or issue resolution time? I would say that all three are incredibly important. Off the bat, usually why customers are interested in our solution is that it really decreases their time to market, especially when they have time-critical projects, especially involving cloud providers. Time to market and provisioning time is probably the greatest driver. As time goes on, customers use the service for longer. The issue resolution and the visibility and the metrics that they can consume out of the service that make our network, you know, just as visible as their network is, that definitely becomes the greater factor. And it doesn't look like there are any more questions, so I will turn it back over to Robert.
Okay, thank you, Anna. And I think there's for any additional information, feel free to follow up with us. In terms of, we have plenty of ample automation resources on juniper.net as well as on PacketFabric.com. We will also be posting the recording of this particular webinar. And again, thank you for your time and for Anna and team to present this material today. I'm looking forward to the next webinar with you. Have a great day.